Okay, guys. Told you I was going to show you how I made those, and here's here's how we did it. This is the magnet. See if I can get a good close up of that, and you can see that I put that box around it. Okay. Then I made a little bit bigger box, and then I made an even bigger box. And I tried to keep the height of the boxes about the same, except for the addition of the internal. I left about 1/8 of an inch more for each layer of the foam that we put down to the bottom. And then we just had a general cap. All that really does is keep things from flying apart. Okay, so how did I do that? It's real simple. You guys might have already figured this out yourself, but for those that would like a little better information on it, I'll try and demonstrate that right here. What I did is I took the metal, and just for well, I'd like to clarify something too. This is a 3/8 magnet. I posted that it was a half. I thought they were half, and I really didn't pay attention to it because I didn't measure anything. And these are 3/8 that I used. So what I did is I took the magnet, a piece of sheet metal, and I used 2 hands at the time, and I just drew a box around the magnet. All right. So let's say this is our magnet, right? So I drew a box around the magnet, and then what I did is I drew 4 more boxes that were exactly the same size, for the first one anyway, okay? And I took and I cut that whole piece out as one large square, alright? Then what I did is I only cut the sheet metal in 4 places, just like that. All right, that's all I did. So then what I did is I took and I folded each one of these inward, which left a flap, and then I overlaid the flap. So I actually have 2 layers of material when it's all put together. So I could show you on this one. I'll undo the flap here off screen and show you how the flaps for each one stick out. Okay, so you can see the flaps, how they, even though I've got the box, the 4 sides of the box, by leaving that material on there, then I'm able to fold the flaps over, and that closes off the corners so that the corners are completely sealed, and that helps reduce flux leakage. Okay, does that make sense? And then what I did for the next one, I basically did the same thing. I added a little bit more material for the rubber that we put around the magnet. Okay, so that's what I wanted to show you guys, how that's put together and how I did that. Did that with all 3 of them, and then assembled it with the padding, 2 layers of padding on all 5 sides. So I wanted to also demonstrate that I didn't really get a good demonstration of it before with the needle. It was hard for me to see anyways on the screen, so I'm going to demonstrate it the same way that I did the very first time, and hopefully this will show us what I first saw, and see what you guys think. I wish this thing would stay in one place. Alright, there she goes again. Well, you know what? I'm just going to take that off because I don't need it moving for this test. What I did is I took this screwdriver and I just kind of hung it loosely in my hand, and I brought it right down into that slot. And when I did, I noticed that it moved away. And I'm like, well, why is it moving away? You know, there's a magnet in there. You know, ferromagnetic material should always adopt whatever pole the magnet has, right? So why is it moving away? And that's what got me wondering, you know, why it wouldn't drop right down in there. And I found out that it has that on all the edges, even on the back side. There's a certain amount of that, which I might be able to demonstrate here with the needle. I don't know. I'll try and see. Get this right out of the way. Alright. It's a really strange phenomenon, because the needle itself is primarily attracted to the center, but when I come up over the edge, it moves away. It doesn't go up against the corners. Okay, so I hope that demonstrated that for you. On to the next.